Here in front of you is a large test tube containing solid copper 2 sulfate pentahydrate. What I'm going to do is, with the aid of this Bunsen burner, heat the contents in this test tube, and as the test tube is being heated, the solid changes color from blue to white, which confirms that water is being driven out of this sample. And one can see water noticeable by the moisture above the solid. So as a result, heating copper 2 sulfate pentahydrate leads to form two products: water vapor and copper 2 sulfate without water, as noticed by the white solid color seen here. Now, what happens if you add water to this test tube? Well, if you do that, the solid will return back to blue, and if you add too much water, it can dissolve to form aqueous solution of copper 2 sulfate. Here in front of you is everything needed to perform the decomposition of copper 2 carbonate. In the test tube seen here, copper 2 carbonate is present, and on top of this test tube is a glass delivery tube, in which the rubber tube is inside a second large test tube containing lime water, which is saturated calcium hydroxide, and 1 drop of phenoldiene indicator, which turns this solution to pink. What I'm going to do is, with the aid of a Bunsen burner, is heat the contents in this test tube, and as it's doing so, bubbles start to be noticeable in the second test tube, confirming that a gaseous substance is being produced in the form of carbon dioxide. As more carbon dioxide is being produced, the color of the solution slowly changes from pink white because the formation of calcium carbonate has been formed. In addition, in the original test tube, copper 2 carbonate, which was originally a greenish solid, has now turned black because the formation of copper 2 oxide has been formed. In conclusion, copper 2 carbonate, when heated, breaks down to form copper 2 oxide and carbon oxide, and the carbon oxide that was produced reacted with lime water or saturated calcium hydroxide to form calcium carbonate and water.